Now let us look at the radius of convergence for these two power series. So you have y1 equal to summation n equal to 0 to infinity minus 1 whole raised to n x power 2n by 2 into 4 etc. 2n. So when you take limit n tends to infinity, mod an plus 1 by an. So we'll get limit n tends to infinity. So an plus 1 will be x raised to 2n plus 2 by 2 into 4 extra 2n plus 2 into 2 into 4 extra 2n by x raised to 2n. So upon cancelling you will get mod x square by 2n plus 2. So when you take limit n tends to infinity, so limit will be 0, so which is less than 1. So therefore by ratio test, the series will converge for all values of x. So again for the second series, so second series can be written in the general form, summation n equal to 0 to infinity minus 1 whole raised to n x raised to 2n plus 1 by 1 into 3 into 5 extra 2n plus 1. Again take limit n tends to infinity mod an plus 1 by an. So limit edukkumbo again 1 into 3 into 5 extra 2n plus 1, that will cancel off. So remaining you will have x square by 2n plus 3. So when you take the limit as n tends to infinity, again the limit is 0, so which is less than 1. So therefore the series will converge for all x. So therefore the power series of both y1 and y2 will converge for all x. So that's what we are asked to prove.